Hi guys, welcome to Little Wicket Railway. I'm Rob, and in this video we're looking at automation using simple signalling logic and dispatcher in JMRI. In my previous technology videos we've looked at the DCC++ base station, the sensor hub, servos and the block occupancy detectors, and now it's time to bring all those things together. If you haven't seen those videos, then it might be worth going to take a look, or watch the end of this video, make sure it's something you're interested in, and then you can always go back afterwards. Thank you to everyone who's watched, liked and commented on those videos. I really do appreciate your support and I hope you're finding them useful. If you haven't subscribed already, then please do, and remember to hit that bell icon so that you'll be notified when future videos come out. Before we go any further, I should just warn you that implementing automation on a layout can be a very complex process. It can be very time consuming and sometimes very frustrating. Asking your computer to control your layout is like giving someone a controller and asking them to operate a train when they can't see the layout. You need to provide them with all the information they need to decide whether to go forwards, backwards, how fast to go and where to start and stop. All that information is provided by sensors on the layout. And even with a really well-designed network of sensors, there are some things a computer just won't be able to handle. For example, if a train derails or stalls. And that's why it's really important for you to have really clean and reliable track work before we even begin. And your wiring also needs to be really good, because the computer won't know if a wire's come loose or a sensor's giving a false reading. So set your expectations now. If you want automation, then you have to be prepared to work for it. However, once you see your trains moving around your layout, changing signals and stopping at stations all on their own, then it's definitely worth it. And there are tools that can make this process easier, and a couple of those we'll be looking at today. Another thing to say is that automation isn't for everyone. Some people really enjoy controlling the trains themselves. However, I think there's something for everyone in this video, from having a small amount of automation where you're still in control of the trains through to full automation with the computer taking control. And also you could have a mix and have somewhere in between. Everyone's layout and requirements are going to be different, and the subject of automation is vast. This is just a demonstration of what I think is one of the easiest ways to implement automation using the tools within JMRI. And just like most things in this hobby, there are multiple ways to achieve the same thing. Even within JMRI, there is more than one way to do automation. And JMRI isn't the only piece of software out there that will do automation. There are other systems available, but I like JMRI because it's free and it's still having features added. So before you commit to an automation system, do your research and make sure it's going to do what you need it to do. Anyway, with all those caveats out the way, here are the steps we're going to follow in this video, and I've listed them all in chapters in the description below. We'll start by setting up our layout with all our electronics. So that's the track, the servos, the signals, the sensors, the base station, etc. Then we're going to set up the JMRI software, including drawing the layout, creating turnouts, sensors, blocks and signals. After that, we'll break this down into 3 levels of automation. Firstly, we'll automate signalling using simple signal logic. So this is where we'll be manually controlling the locomotive, but the signals will react automatically. This will work with both digital and analog layouts. Secondly, we'll use the JMRI dispatcher tool to allocate blocks. So again, we're going to be manually controlling the loco, but this time we're going to set up sections and transits so we can use the dispatcher tool to allocate blocks to our train along the planned route and set signals to protect it. Finally, we'll use JMRI dispatcher to automatically run a train. This is where we tell JMRI that we want our train to go from A to B, and JMRI will take over running the locomotive between those 2 points, automatically setting the points between them. So let's get started. Here is our test layout, and if you've seen the servo videos then you'll recognise it. We've got an extremely short main line that runs from left to right, with a single turnout or point here in the middle that runs into the siding. I've split the layout into 3 blocks which are electrically isolated from each other using pico-insulated fish plates or rail joiners. We've got the main line block on the left here, which throughout will be called left. We've got the siding block here, which throughout we'll be referring to as siding. And then we've got the point and the section of track on the right here, which throughout we'll be referring to as right. Each block has a separate feeder from the power supply, which I've just connected using crocodile clips for now, and this is provided by the DCC++ base station. Each of those 3 feeders is going through a block occupancy current sensor, so we can sense if anything is drawing a current in that block. Those current sensors are connected to the sensor hub, and again, this should be familiar if you've watched my video on how to build the sensor hub. Also attached to the sensor hub, we have 3 infrared sensors, which have been set up at the end of each block by the buffers as gates, which will detect when the train comes to the end of the line. And we've got one final sensor, which you won't have seen before, but it's a micro switch attached to the servo mount for the point. This acts as a feedback sensor to tell us which position the point is in. This brings us onto the servos. We've got the servo for the point, which is connected to the servo driver in position 0. Then, just like the servo tutorial, we've got our 2 semaphore signals with their servos attached in position 1 and 2. As you can see, even for a very small layout, we've got 7 sensors, 3 servos and a lot of wiring. I'm using 3 Arduinos, each with their own USB connection. One for the servos, one for the sensors and one for the base station. It might be possible to combine the sensors and the servos, for example, to save on space, cost in USB connections, but I prefer to keep the systems separate because if anything goes wrong, then I know exactly which board to focus on. The only other thing I need is a loco, so here's my Bachmann Webb coal tank ready to run. That's the physical layout, now onto the software. So let's start by opening JMRI's Panel Pro. And the first thing to do is just double check our connections. So go to Edit, Preferences, and here we've got our 2 connections. So we've got our DCC++ base station, and for me that's on COM5. And then we've got our CMRI connection, which for me is on COM8. Again, that's set up on 9600 board. And then we've got our node set up there on address 1. So that should all be familiar to you if you've watched the previous videos. That's all good. The next thing we're going to do is draw our layout. So in panels, go to new panel, layout editor. And we already did this in the servo video, but we're going to do it again quickly. It's all good practice. So go to options, grid options, and just to make things a bit easier, we're going to snap to grid when adding, and we're going to snap to grid when moving. So we're going to start by putting the turnout in. So we've got a left-hand turnout. Hold down the shift key and left click, and that's facing the wrong way. So we're going to right click on that, hit rotate, and rotate it by 180 degrees so it's facing the right way. Now we can use the right mouse button to just drag this out and make it a bit bigger. Now we'll create some end bumpers. So we'll put this one down here, shift and left click, shift and left click, and shift and left click. Now we'll create some track segments. So up here, select track segments, hold down shift and left click and just drag between the different points to connect it all up. And there we've got our layout. So we'll exit edit mode. Now let's set up our sensors. So go to Tools, Tables and Sensors. And we are going to create some internal sensors. Click Add. And if you've watched the Sensor Hub tutorial, you'll already know how to do this. But we're going to put the address in as 2 and the username in as AR2. And we're going to create a sequential range, and we'll just do up to 60 for now. So that's created our 60 sensors. And the next thing to do is to run the sensor scan script. So back to Panel Pro, Panels, Run Script, go to Desktop and run the sensor scan script. So now our sensors should be live, so we can just quickly check. Yeah, so if I break that sensor gate, you can see that sensor 26 is going active and inactive. I've grouped my sensors into the different types of sensors that I've got. So all my infrared gate sensors are on 27, 28 and 29 on the sensor hub. And because these are gate sensors, they're going to be active unless the beam is broken. So we want to invert these. So in our sensor table, we'll go to 26, 27 and 28 and just hit invert on those. Then we've got the block occupancy current sensors plugged into connections 8, 9 and 10 on the sensor shield. And then I've got my micro switch sensor for the turnout plugged into connection 53. It's worth keeping a note of which sensor is attached to which gate or block, as you'll need to know this later. And it's also worth setting the global debounce settings now. We want our sensors to go active as soon as they detect something, but maybe wait a second before they go off after they've stopped detecting anything. Sometimes the sensor can flicker between on and off, and this will just stop that from happening. So we can set the global debounce settings, and we'll set that now. Under sensors, go to defaults, global debounce settings. We'll leave active, time to active as 0, but we'll set this as 1000 milliseconds, so that's a second. Now, we need to go into each sensor and change this individually. So for 26, go into debounce delays and click use global, hit apply OK. And we'll do this for 27 and 28. And we also need to do this for our block occupancy sensors, which are on 8, 9 and 10. But we won't do this for the micro switch sensor because we want that change to be immediate, and it's never going to flicker because it's a switch. Now we need to set up our turnout, so go to the turnouts table in JMRI. And we know this is set up on position 0 on the servo driver board under CMRI. So we'll go to CMRI, we'll click add. The address is 1001, and for the username we'll just call it turnout for now. Click create. We're going to use 1 bit and a steady state output. And hopefully now if we click on state, we've got our servo working just like we did in the servo driver tutorial. The only other thing we need to do now is click on edit, and because we've got the micro switch which will tell us which way the turnout is set, we can go to feedback, feedback mode, one sensor, and we know this is on sensor 53. Hit apply and hit OK. So the next thing we're going to do is set up our blocks. So go into the blocks menu, hit add. We'll let them automatically generate the system names, but we're going to give it username left for our left block. We'll create right for our right block, and we'll create siding for our siding. Now we can allocate the sensors to these. So our left block is on 8. Our right block is on 10. And our siding is on 9. And this is why it's useful to know which sensors are attached to which section of track. Finally, we're going to create our signal heads. So go to the signal head table, click add, and we need to create 2 signal heads that are driven by CMRI and 2 signal heads which are virtual, and we need 4 because we need 4 to go on 2 on either side of our turnout. So we're going to create a single output, and if you've again done the servo tutorial then you'll already be familiar with this. We're going to give it the system name sh1 signal head 1, and we'll give it username signal 1. Under here, we're going to create new, go to CMRI and type in address 1002. Set your appearances and hit create. Now we'll create the second one. Again, we're going to create new and put this in position 3. I think this one was the other way around. I might have got them switched, but we can fix that later. Next, we're going to create signal head 3, and this is going to be a virtual signal. So we need to create virtual signal head 3, and we'll call this virtual 1. And signal head 4, virtual 2. So we've got our 4 signals, and now is a good point to store your configuration and panels, and we'll call this automation. Now we can go back to our layout editor and start attaching some of the systems that we've just created onto our layout. So go back into my layout, go to edit mode, and we'll start by attaching the turnout. So right click on here on the turnout, click edit, and let's allocate it to turnout. And also whilst we're in here, we can allocate it to our right hand block, and we're going to edit that block quickly. So all this, the basic stuff and the sensor should be set, so it's worth just double checking. But then on layout editor, I don't like it being red, I want it to be blue, so we will just hit apply on there and hit done. Over here we can attach a block, so we're going to go to edit, and again this is going to be our right hand block, so we can hit done. The other thing we can do on here is just tick mainline. And then over here we can go to edit, and we're going to give this block left, hit done, and again if you left click and select mainline, and then over here in our siding, right click, edit, and we'll allocate it the block as siding, so that's done. The next thing we can do is put some of our sensors on. So I know that the sensor at the end of my siding is sensor 26. So we will go to sensor icon and we'll place these on the layout. So select sensor 26, hold down shift and left click, and it drops the sensor on. So now if we were to activate that sensor, I'll quickly activate it. You can see the light goes on and off. So that's just me breaking the sensor gate with my hand. We'll do that with the others. So we've got 28 up here. So let's select 28, hold down shift, left click, and there we go. And then over here, we've got sensor 27. So they all appear to be working. Nearly forgot, in here we need to edit the block and change that to blue. And again, edit this block and change that to blue. Now we need to add our signals onto our turnout. So right click on there and go to set signal heads. So now we need to work through here methodically, allocating each signal head to each position on the turnout. And we're going to just tick this place all signal head icons on there. So once we've allocated them in these drop downs, it will automatically put those in the right position on the turnout. Although it will put them on the wrong side for the UK. It'll put it on the American side, but we can always fix that later. This SSL stands for simple signal logic. And we are going to use this, but we're not going to tick this box. We're going to set it up manually after we've put the signals in place. So for the throat continuing, we want our virtual signal 1. For our throat diverging, so throat diverging, that's the throat, and that's going down this way. The throat continuing is going off this way. So throat diverging, we're just going to put in virtual signal 2. So for the continuing leg, I think that's our physical signal 2, and for our diverging leg, it's over here, that is our signal 1, and so we will hit done on there. Right, let's come out of edit mode, go into here, and we'll save our configuration and panels again. Now we're ready to move on to our first type of automation. So in this first level of automation, we're going to use simple signal logic, SSL, to add some rules to our signals so that JMRI will automatically know if they should be set to danger or not. This will work with analog layouts and digital layouts. This will work for you if you still want to manually control your trains, but it's also necessary for the next 2 levels of automation as well. As I said at the start, this is one of those areas where there are multiple ways to achieve the same thing. SSL works with signal heads, but you could do something similar using signal masks and signal mask logic. But for us, SSL is going to work just fine. So we're going to start by putting the simple signal logic in place. So we go to Panel Pro, and then we go to Tools and Simple Signal Logic. And we have to run through each of the signal heads we've got and let it know which leg of the turnout it applies to and which sensor it's protecting, so which block. And this is where knowing your sensors and which sensor relates to which block is really useful. So let's start with signal 1, which is on our siding, so it's the diverging leg of the turnout, and the sensor it is protecting is sensor 10, and we need to select that it is working on the turnout. So that's saying that when the turnout is closed, it will protect that block, so our right hand block. So we click apply. Next we go to signal 2. This is on the main leg of the turnout. This is again protecting the right hand block, which is sensor 10, and it's going to be when the point is thrown, we want the signal to be red. So we click apply. So now we've got our virtual signals. So virtual 1, and I can't remember which way round we had it, so we might need to go back to the layout here. Just look at where we've allocated the signal heads. So on the throat continuing, we've got virtual 1. So virtual 1 is the main leg, and that is protecting sensor 8. Click apply again, and we've got virtual 2, which is on the diverging leg of the turnout. That's protecting sensor 9. And click apply and close. So now we should have some logic in place. So now if we bring up a throttle and let's select our Bachmann Webb coal tank and we turn the power on, you'll see that the block that the loco is in has been detected. So let's put it through forward. The signal currently is green. What if we were to turn the turnout against it? You see this signal here turns to red and the signal for the siding turns to green. And we've got our virtual signal over here saying that it's okay to go down that way. So let's turn it back and we will move forward and see what happens as we pass through. So it's detected we're in the new block, and I'll stop it there. So this signal's gone to red because the block's occupied. This one's gone to green because we can go back that way. Let's switch the turnout. So the other virtual sensor's gone to green. Let's see if we can reverse. And it's detected us in the siding. Stop there. This block's now clear, and this signal has gone green to say that the block ahead's clear. If we close the turnout, this one goes red because the turnout's set against us, and the main line's now clear. So that is how simple signal logic can be used to automate your signals whilst you are still in control of the locomotive. So in this next step, we're going to use the JMRI dispatcher tool. But before we can do this, there are a couple of extra bits we need to set up. And the first thing is we're going to need to create some reversing and forward sensors for each of our blocks. So if you go back into your tables, go to sensors and go to internal. And we're going to need, we've got 3 blocks, so we need 3 pairs of sensors. So we'll go with hardware address as 101, start a new range, and we'll call these FW1, and we'll add a sequential range, and we want 3 forward sensors. So they're in there as 101, 102, 103, and then we'll add 104, and we'll call these reverse, 1, 2, and 3, add a sequential range, and 3. Now we can go to the sections menu and create some sections. A section is a group of one or more blocks that are connected. For this example, we're going to assign only a single block to each section. So we click on the Add button, and we'll call this left section, because it's going to contain our left block. Now here will be a list of all your blocks. So we've got left, right, and siding. We're going to add selected left block in there. And because we've set all the blocks up on our layout, the computer knows that the entry into left block is from right block, and that direction it's set as reverse. So we're going to define anything moving from right to left as being reverse, anything moving from left to right as forward. Now we need to give it some internal direction sensors, and the computer just uses this when it's allocating blocks and sections to locomotives. It's not something that you will ever need to change, but we do need to include them for the system to work. So we'll just give this FW1 for forward and RV1 for reverse. And at the end of our left block, we've got sensor 28, and this will tell the locomotive where to stop. So for the reverse stopping sensor, we'll put that in as AR28. And then we can hit create. And now we need to do this again for right and siding. So right section, add the right block, and it knows that there are two ways into the right block. So there's from the left, which is going forward, and from the siding, which it thinks will be reverse. But what we're going to do is just change that to forward, because that's moving from left to right, and we're defining that as forward. Again, we need forward and reverse sensors. So this can be FW2 and RV2. And then again, we've got a sensor at the end of the track, and this is a forward stopping sensor. So that can be AR27. That's our infrared sensor at the end of the right block. And we'll hit create. And lastly, we've got our siding. Add the siding block. It knows the only way into the siding is from the right block, and that's going to be in the reverse. Again, we need to allocate forward and reverse sensors. So this can be FW3 and RV3. And then we've got a stopping sensor, the infrared sensor at the end of the siding, which is a reverse stopping sensor, and it's AR26. And that's our sections created. And now we've got these in place, we can move on to transits. So transits tell the computer how a locomotive can move between the different sections we've just created. So hit add, and we're going to create a new transit called left to right. So we start down here, we select our left section, and the computer knows the only section that can move into is the right section. So we'll click add section. And that direction is forwards. It knows that from the setup we did in sections. So we'll hit create on that. We're going to add another transit from siding to right. So this will go from siding to right, and we can hit create on that. And then we'll create the transit right to left. So we start on the right, and then we move to the left. And finally, we'll create the transit right to siding. Add the right section, add the siding section, and it knows it's in the reverse direction, so we hit create. Now is a good time to store your configuration and panels. So that's everything we need to start using Dispatcher. So if you go into your Panel Pro, go to Tools and go to Dispatcher. And this is adding an element of realism into running your railway. So we're still in this step going to control the train manually. So the first thing we're going to do is go to Options and Dispatcher Options. And the key things to check here is that we're using connectivity from the Layout Editor panel, we're using My Layout, and we're using the signal head logic, not the signal mast logic. and that we're using trains from the roster. So we'll click apply, and then it wants us to go file, save options as well. So now we can click on new train, and we're going to take our loco, which is currently in the left block, to the right block. So that's our transit. The backman is our locomotive. The train is in the selected transit, so the starting location is left and the destination is right. We're going to allocate, so these will be the sections that it's going to allocate to this train ahead of where it is now. We've obviously only got one section ahead of our loco at the moment, so we'll just go as far as possible. We're not going to tick any of these boxes except for terminate when done, and we won't tick any of this at the moment. We'll come back to that, and then we'll hit create. So that's my fault. The reason it can't find a train in that block is because our power is still off. So if I turn let's hit OK on that and turn the power on and hit create, there we go, it's detected our train. And if you were to look on layout editor now, you'll see that the right hand block has been allocated to this train. So we'll bring up our throttle, and also at the same time we'll bring up dispatcher. So we'll put dispatcher down here, I'll put the throttle down here and leave room for the video in the corner. So just watch, as we drive our train, this will obviously switch, as we've seen before, from being allocated to occupied, but also watch down here where it keeps track of what's happening. So because we've made it from the left block into the right block, our active train has terminated because we clicked the terminate at the end box. So this is where you can add an element of realism to your railway, and you can start allocating transits to certain trains. So even though you're still in control, the computer will not allow another train to be allocated to the blocks that are already assigned to your locomotive, and it will set the signalling to reflect that. In the next section, we're going to let the computer take over running the loco altogether. So in this third section, again, we're using dispatcher, but this time we're going to let the computer have a go at actually driving the locomotive as well. So again, hit new train. This time we're going to go from right to left because our locomotive is in the right hand block. And again, we're using the backman. The train is in the selected transit, so it's in right and it's going to the left. We'll allocate as far as possible to this train, which is only one block in our case, and we will terminate when done. This time we're going to tick the run train automatically box. So the main thing to check on here is that the speed, we'll change that to 20% because otherwise our loco is going to go flying and it's only a short stretch of track. Because our loco is moving backwards, we need to hit run in reverse, and then we hit create. And now watch what the computer does. It starts driving the train automatically from right through the point to the left. And now hopefully it should detect the train at the end sensor and stop it. And there we go. Now I'll show you some of the other features that you can use using dispatcher to automatically run trains. So hit new train. We're going to go from left block to right block. The train's in the left block and we're going to right block. We're going to allocate as far as possible. This time we're going to reverse at the end. So we're going to go back and forth. And we're going to run our train automatically. We're running forwards to start with, and our speed is 20%. So let's create that. Now at the moment it's not doing anything because the point is set against it. So let's change that and see what happens. The train's now got the green signal to proceed, so it's moving forwards. As it switches blocks, the signals change in response. Slight stall there. It's been detected at the end and it's moving backwards. Up here you'll see the auto trains box has come on, so if something was to go wrong and you needed to manually control it, you can hit this to manual button, or you can stop all your auto trains together. Another example, let's go from left to right and then right into the siding. And we have to do this as two transits, so we go left to right first, train in the selected transit, run the train automatically, and we're going forwards, so we'll create that. And off we go. So now we need to go from right to siding. Train's in the selected transit. I'm going to run the train automatically in reverse. And there we go. So that's how you can start automating things using Dispatcher. The other useful option in here is restart when done, so continuous running. So you could have a train running backwards and forwards continuously. And there are ways as well to put delays into there. If you're wondering why the signal in the siding is still showing red, even though the turnout is set for the siding and the block ahead of it, the right block, is unoccupied, well, that's because Dispatcher has been using the forward and reverse internal sensors that we set up earlier, and at the moment that area is set in a reverse direction, and therefore the signal, which is protecting a forward direction, is showing red. If we want to reinstate our simple signal logic rules, then what we need to do is go into our sections table and go to remove direction sensors from logic. Then we can go back to here and you'll see our original logic has been reinstated. That's just something to be aware of if you want to switch between using Dispatcher or manual control. Something else to be aware of, you may have noticed that the Dispatcher wasn't automatically changing the points. So let's set the point against the siding and go back into Dispatcher. And the setting I've changed now under Dispatcher options is trust the known state of a turnout. I've unticked that box, hit apply, and saved my options. So now I'll create a new train going from siding to right, and we'll run the train automatically, run forward. Now, because I've unticked that box and the turnout is in the next section that it's going to allocate, it should set that turnout for us now. So there we go, that's changed that. Something to be aware of, if we were to run this train in reverse, because that turnout is in the initial section, it won't change that automatically. It only changes turnouts in allocated sections in the future. And I don't know of a way to change that other than what you could do is make that turnout a completely separate block and section. And then it would, every time, change the turnout for your train. Another useful feature of using Dispatcher and transits is that you can generate actions. So if you go into the transits table, hit edit, you can see that there's this add, view, edit actions button. And it's all sorts of things that when it goes into the section or leaves the section or enters the block, or there is a sensor activated, you can get it to do things. So you can maybe delay, pause the train, change the speed, sound a horn, anything like that. So there really is a lot of flexibility with this system. If you want more information about Dispatcher, then JMRI.org has a whole section dedicated to it, and it'll take you through everything we've discussed in this video and a few extra bits as well. So it is worth taking a look at. So I appreciate that this video was pretty long and quite technical, so congratulations if you've made it this far. As I said at the start, these are just a couple of tools you can use to start automation, but I think they are the easiest to set up. We could have also used a system called warrants in JMRI, or we could have written our own Python scripts. That's probably the most powerful way of doing automation in JMRI, but it's also the most complicated. Hopefully you found this useful. Please give me a like and a subscribe. Thank you for watching, and I will hopefully see you again soon.